Hello everyone, welcome to Math Freaks. Today we are going to discuss basic mathematics, and in the first topic we have with us Wavy curve method. So it's a very important method, so let us discuss. So our topic is Wavy curve method. So first of all, what is the use of this method, right? So if you wish to write, you can write. So it is used to find the set of solution of an inequality. So from this we get to know that this method is used to find the set of solution of an inequality, and this method is used only for inequalities. So let's now see how to use this method. For example, say we have x minus 2 multiplied by x minus 4 is greater than 0. It's 0, okay. I have taken here factorized form, but in the questions it will not be in the factorized form. Rather, it will be an expression which you have to factorize. Okay, so first step is you have to factorize it. Let me write the step. Step 1, factorize it. Okay, once you are done with the factorization, you will end up in this form, something like this. So in my case, the two factors are x minus 2 and x minus 4, and this whole expression is greater than 0. So what we have to do is equate each and every factor to 0. What do I mean by this? I mean that we have to equate x minus 2 is equals to 0 and x minus 4 is equals to 0. Now what is the use? This will give us two critical points of this expression. What do I mean by that? I will explain you in the meanwhile. Okay, so our two critical points would be x is equals to 2 and another will be x at 4. Now our second step is also done, so let me write the step 2. Step 2 you have to do is equate each and every factor of the expression to 0. Right? I hope you understand the two steps. First you have to first of all, let me repeat myself. First of all, Wavy curve method is used to find the set of solution of an inequality. That means you can use this method only for inequalities. Then the second step, or the first step, is you will be given an expression in the question. We are going to discuss few questions of Wavy curve method. So the first step is to factorize the expression. Now when you are done with the factorization, you will end up with some factors of the expression. The second step is to equate each and every factors of the expression to 0, like we have done in this case. Right? Now if you are done with the two steps, the third step is draw a number line and put only these two critical points. Like this is a number line, okay, and you will also put only the critical points. In this case we have only two critical points, that is 2 and 4, right? Only put 2 and 4, don't put all like 0 and this and that. Only put the critical points that you have found out by factorizing the expression. Now what? Here comes the exciting part. You have to remember some points. This might be a bit confusing if you are trying this for the first time. So what next step would be, after putting the critical points on the number line, the left side, this portion, right, this portion, first of all you have to do, make it positive. Write positive here. Do as I say, write positive. Now we have to look at this portion, if it will be positive or negative. For this we have a rule. So from where we have got this critical point 4, from which factor we have got this critical point 4, we have got this factor from this x minus 4, this x minus 4, from this factor we have got the critical point 4. Now look at the power of this factor. What? Okay, again we have to make the left hand side positive, and then the first critical point that we look at, we have to find from which factor we have got this critical point. In our case it is x minus 4, so we have to look at the power of x minus 4. In this case it is 1, right? Now here is a very important rule. I want to write it down. If power of the factor is odd, then there will be a sign change. Okay, and if the power is even, then there will be no sign change. You can write that. So what did I say? If the power of the factor is odd, then there will be a sign change. Now look at this. This is 1. So tell me, is this odd or even? 1 is odd, right? So we have put here plus, then we have come across 4. We got this 4 from x minus 4, and we see that the power of this factor is 1. So there will be a sign change. So from plus, this will be minus, right? Because here was plus, and since the power is an odd, so we have to change the sign from plus to minus, right? Now again we have to look at the second critical point, that is 2. Now again we have to see from which factor we have got this critical point 2. So in our case it is again x minus 2, and the power is again 1. So you tell me, will there be a sign change or not? Will there be a sign change or not? Yes, obviously, because the power is 1, which is odd, and since here was minus, so the sign will be changed to plus. Am I clear? Am I clear? Let me repeat again. So first of all, put this left hand side positive, then the first critical point that you come across, look from which factor you have got that, check the power. If it's odd, then change the sign, that is from plus to minus. And if again you have to look at the second critical point, and if the factor from which you have got this critical point is the power is odd, then you have to change the sign again. In this case all the powers were odd, so we have to change it simultaneously. So now here comes the final part, that is, see, x minus this expression is greater than 0. Do you understand it? Greater than 0. So greater than 0 is positive, right? Greater than 0 is positive. So we have to take all the set of values that is in the positive side. See, from 2 to 4, this particular region I'm talking about, from 2 to 4, this region is negative. So if we take any value between 2 and 4, the expression will not be satisfied. This inequality will not be satisfied, and we will take an example. So since it is greater than 0, we have to take the positive region. So in our number line, the positive region is from plus 4 to infinity, and from minus infinity to plus 2. So this is the positive region, and this is the positive region, and if we take any value in between these two regions, then it will satisfy our inequality. So finally, how to write the set of solution? Since okay, I have not taught you the interval notation, I will teach you after this. So we will write this as minus infinity comma 2 union 4 comma infinity, right? Now what is this union? You can say this is the this is like addition of sets. Like this is one set, this is another set. If we have to take like both the sets, then we write union. And okay, leave that part. So I hope you understood that when we take two sets and we want to take it together, we say it union, like addition, you can say, kind of, right? So now let's see what happens if we take a value in between the negative region. See, I'm telling you again, since this whole expression is greater than 0 or positive, we have to take the set of values that is in the positive region, that is from 4 to infinity and minus infinity to 2. Now let's see, what if we take a value in between the negative region? For example, say 3, right? 3 will be in this somewhere here, 3. So if we take 3, let's see if it satisfies the inequality. So put x as 3, so we get 3 minus 2 multiplied by 3 minus 4. So as you can see, it is very clear, it comes to be minus 1, which is not greater than 0, it is less than 0. So I hope you understood that why we have taken the values that are in the positive region, because the inequality is telling us to take the values that is in the positive region, otherwise the inequality will not be satisfied, right? Now before moving to the questions, I want to tell you the notations of these intervals. So it's very easy. Let's start with this notation that we just saw. This is known as open bracket. You can call it open brackets, right? Now why we use this open brackets? Let's say there's an say that the previous example, okay, so it was from minus infinity comma 2, right? Open bracket. Now why open bracket? See, open bracket is used to we mean by that, if we have written some, okay, not this example, let's make it is easier for you. Let's say we have taken an example of 2 comma 4 open bracket. So what do we mean by this is, we will take all the values in between 2 and 4. It can be irrational, rational, anything. All the values between 2 and 4 excluding 2 and 4. What do we mean by open bracket? Take all the values, any value, irrational, rational, that doesn't matter, all the values except 2 comma 4. This is what we mean by open bracket. Some people also write it as this. This is also a good notation of this open bracket. I hope that this is clear. Now let's take another example, say 5 comma 7 open bracket. So what do we mean by this? We mean by this, we will take all the values between 5 and 7 except 5 and 7, right? So in the previous example that we saw, see, here is minus infinity comma 2 open bracket. So why 2 open bracket? So now you can check it by yourself. If you put the value of x as 2, it comes 0, like, right? The whole expression comes to be 0, but you can see that this is greater than 0. This cannot be equals to 0. The expression has to be greater than 0. That's why it is not included in the set of solution. Similarly, 4 is also not included in the solution. Why? If you put x as 4, again the expression comes to be 0. I hope that you were able to understand why we did not include 2 and 4. Now let's talk about the infinity. Why we did not include infinity? Now infinity is something that we cannot get, right? Infinity is something that we cannot include in our solution, because if we include infinity in our solution, it will not be defined. Like, you can think of infinity as such an quantity that is not achievable, I would say. So that's why we do not include infinity, right? I hope that this first notation is clear. Now let's move on to the second notation, that is closed brackets. This is known as closed brackets. This is C, closed brackets. Now if I take an example, say 2 comma 4 closed. Now what do we mean by that? This is very simple. This means that we have to take all the values between 2 and 4, and even now this time we have to include 2 and 4. So all the values between 2 and 4 including 2 and 4, or I think this would be a better sentence, all the values from 2 to 4. Now in this case we have to include 2 and 4. In the open bracket case we have to exclude 2 and 4, but in this case we have to include 2 and 4. Like if you take another example, say 10 comma 11 closed, so all we have to take all the values from 10 to 11. But in the same case, if we write 10 comma 11 open bracket, then we mean that only the values between 10 and 11, but not 10 and 11, like excluding 10 and 11. But when we write in the closed bracket we have to include 10 and 11, right? So I hope that these two notations are clear. And the last notation is not very commonly used, but in your JEE preparation you might find it. So this is the curly bracket, right? So example, easy, it's very easy. Say curly bracket 17 comma 19. So what do we mean by that? We have to take only 17 and 19, nothing between them, only 17 and 19 we have to take. Or say 8 comma 9, this means that only 8 and 9 we have to take. Okay, I hope that this is clear. Now if someone asks you to give the what do we mean by this one, can you say this? Can you explain this to me? This is very simple. This means that all the values between 2 and 4 including 4. Why including 4? Because see, 2 is open. 2, like how you should read this, you should read this 2 is open. 2 is open means that 2 is excluded and 4 is closed. Okay, so 2 comma 2 open, 4 closed, so 4 is included and 2 is not included. Another example you can say is 0 comma 3. What do you mean by that? Read this as I have said you, like 0 is closed. What do we mean by that? We mean that 0 is included and 3 is open, that is 3 is not included. Another like this, you can practice it by yourself, right? I hope that the notations are clear and this one is also clear, the Wavy curve method. Now let us practice some questions. Okay, so see, let's take an example of x square plus 3x plus 2 is greater than or equals to 0. Find set of solution of x. Okay, now pause this video and try it by yourself. Done. Now let me move on with my solution. Now this can be easily factorized. What will be this? X square plus 2x plus x plus 2 on x plus 1 multiplied by x plus 2, right? This is greater than or equals to 0. Now what? Now our first step is done, that is we have factorized it. Step 1 checked. Okay, now let's move on to the step 2. What? That we have to equate the factors to 0. So x plus 1 and x plus 2 equate it to 0. Then what we will get from this 2? From step 2 we will get the critical points. So first critical point being -1 and the second critical point being -2. So step 2 also checked. Now let's move on to the third and the final step, from which we will get our solution. Draw the number line. Okay, say now which you have to write the smaller one before, right? Like the in the normal number line. So -2 and here -1, correct? Because -2 is smaller than -1. So again, then you have to make the left hand side positive, right? Now we come across the first critical point, that is -1. So you have to check from which factor you have got -1. In our case, this is this factor. Now look at the power of the factor, which is 1. This is again odd. So if this is odd, we have to change the sign from plus, it will be now minus. And now we come across another critical point, that is -2. Now check from which factor we have got -2. This is this factor. Then look at the power 1, which is again odd. Then again change the power sign. Now you have, now see, this is greater than or equals to 0, right? This is greater than or equals to 0. So we have to take the positive, right? We have to take the positive side since this is greater than 0. So this side and this side. Now which notation will you use? Remember, this is not greater than 0, but now this can also be equals to 0, right? This can also be equal to 0. Now when this, now if this is equals, now if you get something like greater than or equals to 0, then you have to include the critical points, right? You have to include the critical points. So how will you write the set of solution? So you can write it as minus infinity, because we can never include minus infinity or infinity. So the solution will be minus infinity comma -2 open bracket, no, this time included, union, again included, -1 comma infinity open. Now now if you want to check, you can check the, just put the value of x as -2, you will get the expression is equals to 0. But in this case it can also be equals to 0. That's why I was telling you to include the -2, because in this case we can, even the expression can be 0. That's why. I hope that this question was understood by all of you, and this is a very simple question. Now let's take an example. Say x plus 1 whole square multiplied by x minus 2 whole cube multiplied by x minus 10 is less than 0. Find set of solution. Find the solution of the expression. Solution. Try it yourself. Done. Now let's begin. Now you see, now the powers are not odd. So let's try it again step by step. I have not given here in the factorized form because this example has come to my mind now, so I have no time to factorize it, like expand it. So let's follow the steps. Step 1, which is already done in the question. So now step 2. What was the step 2? Step 2 was to find the critical points. How we can find the critical points? Equate the factors to 0. So I'm directly writing now. X can be -1, x can be 2 and 10. These are the 3 critical points. So step 2 is also done. How we have found out? Just equate all this equals to 0, then you will find the critical points, right? Now step 3 was to put it in the number line. So -1, 2 and 10. So -1 first because it is the smallest, then 2, then 10. Now here we have 3 factors, but 3 critical points, but this is easy. Again follow the steps. Put the left hand side positive region, right? Next, what is the critical point here? This is 10. From which factor you have got 10? which is x minus 10. So in this case it is even, sorry, odd, so we have to change the sign. So after changing the sign, plus will become plus, no, minus. So from 2 to 10 the region is negative. Then we come across another critical point, that is 2. Now we have got 2 from this factor, but again here the power is 3, which is odd, so again we have to change. So this will be plus. And now finally we have come across the last critical point, that is minus 2. And if we check at the factor from which we have found out minus 1, it is even. So what was the rule? That if the power is odd, then only we have to change the sign, but since the power is even, we don't have to change the sign. So our last sign was plus, so it will also be plus. There will be no sign change. Now again look at the inequality. The expression is less than 0, so we have to take the region where we have to take the negative region, right? So we find that the only negative region is between 2 and 10, correct? Now it's between 2 and 10, so since it is only less than 0, not equals to 0, only less than 0, so we have to use the open brackets. So finally you can write your solution as x belongs to 2 comma 10. Now this notion is called epsilon, and this is used to belongs to, here belongs to denote belongs to. So this is the solution of this question, 2 comma 10, and they both, and in the open bracket, that is 2 and 10 are not included, but the values between 2 and 10 are included. Now if you just doubt me, let's check one solution in the negative region and let's see if it satisfies. So minus 1 to 2, so let's take 1. So if we take 1 here, so what will be this? If you put x as 1, so this will be 2 square, which is 4, multiplied by so 1 minus 1 you have to multiply, and then from here minus 1 minus 9, right? So this will be 36, which is not less than 0. So see, if you take a value in between the positive region, the answer does not satisfy the expression or the inequality. So this was all about the wavy curve method. I have told you all the possible cases, like this was also an interesting question, this was also an interesting question, and these are the notations of the intervals, and this was the whole process. I hope that this wavy curve method is clear to all of you. Now let's move on to our next topic, which is modulus function. Modulus function, it's very easy. Modulus function, now this is denoted by 2 lines, okay, 2 lines. Now how I want to make you explain about modulus function is that think of it as a machine, like some kind of a machine. So here is the input, and say here's the output, input and output. So this is modulus machine, say for now, this machine, okay. Now if you put any value like negative, positive, anything, it will always give you a positive value. Like the number will be same, but the sign, if it's negative, then it will be positive. Like if you put here minus 5, you will get 5 from the output. If you put here minus 10, you will get 10. If you put 1, you will get 1. If you put in this machine positive values, then it will give out the same. If you give it negative values, then it will change the sign and give you the positive number. What do I mean? Now if you are confused by even this example, let me explain you normally. Say if you take any number, say -5. So what did I say? If you put any negative value, then it will give you the positive of that value. So here is -5, so it will, if you put it in to the modulus of -5 will is 5. So and again if you put as 5, this will come out to be 5. Okay, this will come out to be 5. Now what do we understand by this? Anything, the thing that will come that will be here, like after you do the modulus of that thing, it will give out the positive one, positive version of that. So if we take any number, say x, and do the modulus of that, we are going to get two values, right? We are going to get x if x is greater than 0, and we are going to get minus of x if x is less than 0. Now few students may ask me, sir, you have told that whenever we do the mod we get a positive value, but here you are saying that we are going to get minus x. How is that possible? Because you missed one condition, that x is less than 0. So if I take -2 and multiply it with the minus, then we are going to get 2. So this will also remain positive. So think positive and you will get the answer as positive, right? Now I hope that this one is clear, and now let's move on to the rules for modulus function. So rules of modulus function. Now first rule is that if mod of x whole squared is equals to mod of x square, this is the first rule, and this you can check with some examples like any number. Second is x1 multiplied by x2 is also equals to mod of x1 multiplied by mod of x2. For example, say 2 and -4 multiplied, you can do, if you multiply then to the mod, you are going to get 8, and if you do the individual mod of the numbers, you are also going to get 8. Now is it only applicable for two numbers? No, this is applicable for n numbers, like any number of any, what to say, that n times of numbers, this is possible. Now third one is that x plus minus y is never equals to x plus mod of x plus mod of y. Not never, this is equals to, for example, say -3 plus 4. From here you are going to get 1, but if you do the individual mod, you are going to get 7. Like mod of -3 plus mod of 4, you are going to get 7, right? You can take many more examples. Now I told you that this is not always, so when this condition will be false, when x will be greater than or equals to 0. I'm not talking about the minus, I'm talking about the x plus y. So fourth is that x plus y is equals to mod of x plus mod of y if and only if x is greater than 0. This condition is a must condition, that x has to be greater than 0, and this is very logical as well. You can think of numbers and add them, you will get the same result. Now next rule you can say is that if mod of x1 upon mod of x2 is also equals to mod of x1 upon mod of x2, again take examples of numbers and you can find the same. So these were some rules about modulus function. Now one very big mistake that students make is, I'm showing you, let's take an example of x minus 1. So if I ask you to tell me the possible values of this. So people like students say that, sir, it will be x minus 1 for x less than 0, and it will be x minus 1 for x greater than 0. This is totally wrong. See, we know that we are going to get two values, but the condition must be applied that whenever you are given an expression in between the two straight lines or mod, you have to take the whole expression as a unit. What do I mean by that? So the two possible answers are x minus 1 for x minus 1 greater than 0, not x greater than 0, and x and minus of x minus 1 for x minus 1 less than 0, not x less than 0. I hope that you understand this point. This is an important point. Make sure you understand that. Okay. And okay, one rule I forgot to tell you. One more rule. This is not rule, this is a general talk. Like I'm adding this here. Fifth one is that this is like very normal. Okay. And another okay, up to this much is on, so okay. So this was one rule that I wanted to add, and this is an important thing to remember. So what is the conclusion of this one? Whenever you are given a expression in between the mod, you have to take the whole expression as a unit and then apply the condition to find out the solutions. Now let us do some questions. Okay, so one question is that mod x minus 2 mod minus 5 is equals to 2. Okay, so mod of x minus 2 minus 5 is equals to 2. Then find solution of x. Try it yourself. Done. Let's begin with our solution. So this will be equals to mod of x minus 2 is equals to 7. Now whenever we do the mod, it's like even when we do x, we are going to get plus minus x, right? So why not we apply that condition here? So the two possible answer is x minus 2 is equals to 7, and the possible answer is x minus 2 is equals to minus 7. These are the two possible cases. Now from the first case we are going to get x is equals to 9, and from the second case we are going to get x is equals to minus 5. And now let's say if the two, which of the values satisfy, either one of the value can satisfy or both the values can satisfy. We have to cross check it. So if we put 9 in this place, so 7 minus 5 we are getting 2. So if we take minus 5, so minus 7, and okay, it's also satisfying. Yes, so the both answers are okay. So x is equals to 9 comma minus 5. These are the two values of x. I hope that you understood, right? What did we do? We just used the property of modulus, that mod of x is equals to plus minus x, and since we are getting mod of this is equals to 7, so we can write that x minus 2 is equals to plus minus 7. So from this one we got two cases, case 1 and case 2. We solved for both the cases of, and then we got the value of x is 9 and minus 5. You have to cross check it, right? Now I'm going to discuss one more question, and I will give you assignment where you can solve more questions. Another question will clear your whole conception about mod. This question: Mod of x minus 2 whole mod is equals to 2. In this type of questions, there is a special approach. So if you know, try it. If you don't, wait for me to solve it. Done? You have tried your best. Now let's move on with the solution. Okay, first of all, what can we do? Say if x is greater than or equals to 2. This is case 1. If x is greater than or equals to, see, this portion will be positive. Then if x is greater than or equals to 2, just put values. We are putting a condition for x, that's it. So if we put this condition, then this part will always be positive. So we get that x minus 2 mod is equals to 2. From here we get x minus 4 is equals to 2, right? So the only possible value from here is x equals to 6, correct? Because since we have to take x greater than or equals to 2, so 6 is the only possible value, right? Now case number 2, if we take x less than 2, if it's less than 2, then this will open with a minus sign, right? So if we open it with a minus sign, we will get minus x plus 2 minus 2's mod and equals to 2. From here we are going to get x is equals to 2. So the possible answers are x is equals to 2, right? Okay, wait, one condition is missed in this point. So what we have taken here is minus of x is equals to 2. See, this is minus of x. We have taken x less than 2, but we don't know if x is less than 0 as well, right? Now again, you open, like, this can be plus minus 2, right? Minus of x, like minus of x mod is equals to 2, so we can write this minus of x is equals to plus minus 2, correct? So what we get here is x is equals to minus 2 comma 2, correct? So these are the possible values of x. Okay, don't miss the cases. I just forgot about this case, so don't forget the cases. So the answers of x here is 6 minus 2 and 2. You can even cross check it. You have to cross check it because sometimes we apply the conditions, the answers come, but the answers don't satisfy it. There are some conditions. So I hope that this question is understood by all of you. You can place 6 in the position of x as well as minus 2, so minus 4, and from the mod it will come 4 minus 2 is 2, and again you can also put 2, so this one will become 0, and minus 2's mod is 2, so it is satisfied, right? Now this is the end of Modulus. I was trying to give you a basic idea about Modulus. Now you will get more questions in the assignment. There more interesting questions will be there. You have to try it out. If you don't get it, just type it down. I will try to help you out. Now let's move on to the next topic, the last topic, that is quadratic, like basic quadratic equations. Basic quadratic equation. Now what is a quadratic equation? All of us know that an equation with degree 2, equation with highest degree, like degree 2, What is degree? The highest exponent of an expression, like x square plus 2x plus 3 is equals to 0. This is a quadratic. Why? Because the expression that you see has highest has degree 2. That is, the highest exponent of the variable is 2, hence it is the degree. And one condition is that uh, that the coefficient has to be a integer. You will learn all this in the polynomial section, but for now just think of it as the highest power of x. Okay, there are some more details to it, the degree. Okay, so basically an equation with degree 2 is known as a quadratic equation. There are many ways to solve a quadratic equation. One way is to factorize it, other way is to use the formula, that is the Sridhar's formula, right? First of all, like this type of quadratic equations, you cannot factorize it, right? You cannot factorize it. So what you have to do is you have to use the Sridhar's formula. What is Sridhar's formula? It is, say there's an equation of ax square plus bx plus c equals to 0. This is a quadratic equation. Then the x equals to plus minus b equals to minus b plus minus root of b square minus 4ac upon 2a, right? Minus b plus minus root of b square minus 4ac upon 2a. This is Sridhar's formula. So you see from here is one root being minus b plus root b square minus 4ac upon 2a, and another root being minus b minus root of b square minus 4ac upon 2a, right? Now this part that you see, that the b square minus 4ac is known as the discriminant. This is known as discriminant. A lot of things will depend on this discriminant, right? Discriminant. This is in some books this is also denoted by delta, in some other books this is denoted by simple d. Okay, so we will denote it with d, right? Now you know about the roots of an equation. Like if you don't, like the roots of an equation, see from this say alpha is a root of equation x square plus 2x plus 3 equals to 0. If alpha is a root of this equation, then if you put alpha in place of x, the equation will still be satisfied, correct? I hope that you know what is a root of an equation. So what did I say? If alpha is a root of this equation, then alpha will satisfy this equation. If you put alpha in place of x, then this equation will be satisfied. This is what we mean when we say a root. So the number of root is equal to the degree of the expression. See, this is a quadratic equation with whose degree is 2. So here will be 2 roots. So this equation will have 2 roots. Say all the quadratic equations will have 2 roots. And if we talk about cubic equations have degree 3, so there will be 3 roots. If you take a biquadratic equation, that is a degree 4 equation, then there will be 4 roots, like this. So number of roots, you can say this, is equals to the degree of the equation. Understood? So since this is we are talking about quadratic equations, so it will have 2 roots, right? 2 roots. Now let's talk about the relation between roots and coefficients. Roots and coefficients, I think if you are studying in class 9th or 10th, you must have studied this. Say ax square plus bx plus c is equals to 0 is an quadratic equation. Then and say it has two roots alpha and beta. Okay, so then the relation is something like that: alpha plus beta is equals to minus b upon a, like the coefficients. I am not showing you the proof because proof is not required. You can check it in your NCRT. And alpha beta is equals to c upon a, right? Alpha plus beta is equals to minus b upon a, and alpha beta is equals to c upon a. What do we mean by this? We mean that sum of the roots is equals to minus b upon a, and the product of the root is equals to c upon a, right? Now if you can have a question that, sir, if in the question comes a biquadratic equation, then how will we find the relationship between the roots and the coefficients? Or say not biquadratic, say equation of degree 6, there will be 6 roots. Then how can we find the relations between the roots and the coefficients? Because in PRMO or IOQM such questions have come. So for that case we are going to teach you Vieta's relation, which tells us about the relation between the roots of and the coefficients of any equation. We are going to learn this in the advanced quadratic equation. This is just the basics. So for now just learn the quadratic equations, this relation between the roots and the coefficients, right? I hope that up to this much is clear. Now in this lecture, since this is the basics, so we are going to tell you what is in your NCRT. Like the next topic is also in your NCRT. After you cover your NCRT, we are going to discuss some very advanced theories. So the next is that if again say this ax square plus bx plus c, this is again a quadratic equation. So this has say roots alpha and beta, right? Because the degree is two roots. So if alpha is equals to beta, that is if the roots are equals to are equal, then the discriminant is equals to 0. Understood? Then the discriminant is equals to 0. How, why, we are going to discuss in the next lecture. We are going to show you some graphs of this particular section. It will have all the concepts that we are discussing. You can understand it by the graphs. Second is that if alpha and beta are real, then the discriminant has to be greater than or equals to 0. And if alpha and beta are not real, then discriminant has to be less than 0, not equals to less than 0. Okay, don't I know there are many questions why, how. So we are going to tell everything in the next lecture, that is in the advanced theory of equations. This is the basic one. So up to this much we will cover today. In the next lecture, as I told you, I am going to tell you Vieta's relation, okay? So in the next lecture we are going to tell you Vieta's relation and all this stuff, advanced stuff. So I hope that up to this much it is clear. We have discussed a lot of concepts today, so give your brain a bit of rest. So up to this much we will cover. Now okay, some few things that I missed out in the previous concepts is that in the Wavy curve method, okay, the inequality in the RHS, it has to be 0. You cannot solve this particular inequality for 1 if it's given x square plus 3x plus 2 is greater than equals to 1, you first of all you have to make the RHS 0, then only you will be able to solve this equation or inequality, sorry. So this will be x square plus 3x plus 1 greater than equals to 0. Now you can solve using the Wavy curve method. So you remember this point, RHS has to be 0. This is a very important point I forgot to tell you, right? And in the modulus functions, I think modulus function you may have some doubts, and it's common. So in the next lecture we will also discuss a bit of modulus function more to make your concepts crystal clear. And yes, as we have told you, in the next lecture we are going to discuss also advanced theory of equations. Till then, bye bye, see you in the next lecture. Hope you like this lecture.